Has anyone ever told you that you have an interesting profile? Looking at people from the side can give you a totally different perspective on their appearance. Well, approach chart designers feel the same way, and just below the plan view, they offer you a profile view of the instrument approach, a totally different perspective that shows you your descent path into the airport. Besides altitudes, you'll see the approach fixes, distances between the fixes, and the complete description of the missed approach procedure. And since the profile view is used for the descent, which is the most critical time of an approach, it also shows you your course directions on the approach path arrow, so you don't have to return to the plan view to hunt for them. First, let's take a look at the VOR runway 23 approach to Terre Haute, Indiana, and look at the plan view. In the plan view, you can see that the Terre Haute VORTAC Tango Tango Hotel is the initial approach fix, and that the approach course goes northeast for a procedure turn course reversal, then back southwest across the VORTAC and to the airport. And that is exactly what the profile view shows from the side. So let's take a closer look. Now, in the profile view, even to the most casual observer, it's obvious that you're not going directly to the airport from the VORTAC. Following the arrows, you can see the approach initially takes you outbound from the airport on a course of 049er and then back towards the airport on the reciprocal course 229er. What you're seeing here is the profile or side view of the procedure turn course reversal. The segment of the approach that in the plan view is shown with that bent harpoon. Now, anytime you have a course reversal, you'll usually see a note like this one that says remain within 10 nautical miles. The note means that you must complete your procedure turn within 10 nautical miles of the fix you started it from, in this case the Terre Haute VORTAC, in order to remain safely within the protected airspace that's reserved for course reversals. The number 2300 with a line below it that you see here represents the minimum altitude for the procedure turn, 2,300 feet. Now, when you complete the procedure turn and you're established on course inbound towards the VORTAC, you can descend to the next minimum altitude, 1,700 feet. And speaking of altitudes, let's take a closer look at them. When you see a line below an altitude, it tells you that's the minimum altitude that you can fly that segment of the approach at. And that's the way you'll see the altitudes depicted most of the time. But you may occasionally see an altitude with lines both below and above it, like the one here on the approach to Hawthorne, California. That's called a mandatory altitude, and it means you must fly that exact altitude and nothing else. Since Hawthorne Airport is just a stone's throw away from Los Angeles International and nearly under its many approaches, the reason for the mandatory altitude is to keep the Hawthorne traffic below the big boys landing at Los Angeles. Now, on very rare occasions, you'll see an altitude figure with a line above it, like this one on the approach to Wichita's Cessna Aircraft Field. The line above means that it is a maximum altitude, and the reason it's there is to keep you from conflicting with traffic at nearby McConnell Air Force Base. Now, sometimes you'll find a maximum altitude paired with a minimum altitude, which makes it what's called a mandatory block altitude. With a block altitude, you'd be safe at either the maximum or the minimum altitudes, or anything in between. The maximum altitude is more than likely there to prevent you from mixing it up with overlying traffic routes. If, however, you see an altitude with no lines at all, that's a recommended altitude, which tells you basically that the altitude shown is a good altitude for this position on the approach. But you would also see a minimum altitude to ensure your obstruction clearance. Now back at Terre Haute, what's this X here where the vertical line from the vortex intersects the inbound course? Is that buried treasure? No, it's more important. The X, known as a Maltese cross to students of such things, marks the final approach fix and the beginning of the final approach segment. After you pass the final approach fix, you can descend to your minimum descent altitude. That's the lowest altitude you're allowed to descend to on this approach. The minimum descent altitude is shown down in the minimum section, and we'll look at it later on. Now, one way to determine the missed approach point on this approach, if you have DME or an approved substitute like GPS, is when you're 3 miles from the vortex. Notice that your approach path arrow on the chart changes its appearance at the 3 DME fix. If you do not have DME or an approved substitute, then you could time the approach. We'll talk more later about timing approaches. The profile view uses the same close segmented arrow as the plan view does to show the initial part of the missed approach path. As you can see here, and it will be true on all other approaches, the missed approach profile shows a climb. So, if you do have to go missed, where do you find the detailed information on how to fly that procedure? In the upper left corner of the Terre Haute profile view, you can see that the instructions say climb to 2,300 feet, then left turn direct to Terre Haute TTH vortex and hold. Now, on some approaches, you cannot descend to the minimum descent altitude for the approach immediately after you pass the final approach fix. Instead, you descend some after passing the final approach fix and make your last descent after passing another fix, what's known as a step-down fix. On this VOR or GPS Alpha approach at Newark, Ohio, notice the 6 DME fix from the Appleton Vortex APE. This is a step-down fix on this approach. Your minimum altitude until you've identified and crossed the 6 DME fix is 1,760 feet. Now, although the name of this approach does not say DME, you will need DME or an approved DME substitute like GPS to identify that fix. So, what if you don't have DME or an approved substitute? You can still shoot this approach, but you cannot descend any lower than the 1,760-foot minimum altitude shown at the step-down fix. If the ceiling is above that, you'll still be able to get in. But if you can identify the 6 DME fix, you get to descend lower. Instead of 1,760, you get to go down to 1,520. And in bad weather, that 240 feet might allow you to successfully complete the approach and land. Now, on some non-precision approach profile views, like this one at Elkhart, Indiana, you'll see a bold V on the final approach segment. That V represents the visual descent point, which is the point where you could make a normal descent to the runway from your minimum descent altitude. Even if you have the runway in sight, you should not descend below the minimum descent altitude before reaching a published visual descent point. If you do, you'll be on a shallow landing approach with little or no obstruction clearance. And that, my friend, could be a path to an unhappy future. Let's take a look now at a really unusual approach configuration. This is the VOR or GPS Alpha approach to Brownfield near San Diego. The missed approach point is the vortex, and you can see the segmented missed approach path as it curves upward from there. But notice this heavy dashed arrow just past the vortex. It represents a visual flight path to the airport. When you get to the vortex, you'll fly visually on a course of 157 degrees for 2.3 nautical miles to the airport. Because it says fly visual, you do not have to have the runway environment in sight to continue past the vortex, which is the missed approach point. But since you are flying visual, you must be clear of the clouds by the time you cross the vortex, and you must have the required visibility. In this case, 2 3/4 miles. If you're not visual, you'll need to execute the missed approach procedure at the vortex. Now take a look back at the VOR runway 23 approach for Terre Haute. The notation 3.39 degrees after the angle symbol tells you the descent angle you would program into a vertical path computer, if you had one. Vertical path computers are typically found in the sophisticated flight management systems found in airliners and high-end business jets. Notice also the note that says VGSI and descent angle not coincident. VGSI stands for Visual Glide Slope Indicator, like a VASI. This note simply tells you that if you're flying that 3.39 final approach angle, you should not expect an on-glide slope red over white indication when you pick up the VASI. Because the VASI is set at 3 degrees instead of 3.39 degrees, you'll see a high white over white indication. Now, just below the approach angle, look at the notation TCH 31. No, it does not tell you that number 31 just scored a touchdown. TCH stands for threshold crossing height, and in this example, it tells you that if you flew the approach angle all the way from the final approach fix to the runway, you would cross the threshold 31 feet above it. Okay, now we're about to get small, very small. So take a look at the VOR or GPS Bravo approach to Chino Airport in California. Notice the solid vertical line from the VOR that runs down to the bottom of the profile view. To the left of it, you see a teeny tiny number and some letters, 5NM. That tells you that it is 5 nautical miles from the VOR to the next fix, in this case Hinton intersection, which is the final approach fix as shown by the Maltese cross. Then, from Hinton, it is 4.2 nautical miles to the missed approach point. But these are not DME indications. They're there simply to tell you how far you'll travel in nautical miles between various fixes or points on the approach. So the next time someone tells you that you've got an interesting profile, tell them that you can show them a far more interesting one. For instance, Tweety Bird might recognize these profile view fixes. Itawa Putty Tat, ID'd. By using the information the profile view provides, you can feel comfortable with the descent you're about to make.